I'm Sriya from Mathematical, and today we're doing another class of senior intermediate, and it's going to be on probability. The topics we're going to be covering today are geometric probability and expected value. So our first topic of today is geometric probability. And geometric probability is a tool we use when there are an infinite amount of outcomes. So this is an easier way to do it, and it's also pretty fun. So, for example, your bus is coming at a random time between 12 p.m. and 1 p.m. If you show up at 12:30 p.m., what is the probability that you catch the bus? So, we're going to use a bit of geometry. It's really simple. So, let's try doing it. So, since it's geometric probability, we're going to draw a mini timeline. And our timeline is going to go from 12 to 1 p.m. And we're going to have 12:30 in the middle. So, this entire segment right here is what the bus can arrive at any time between these segments. But we're only going to show up at 12:30, meaning we only have 30 minutes for the bus to show up. And there's 60 whole minutes, and only 30 of those minutes are what we're going to be there for, so the answer is going to be 30 over 60, which is 1 over 2. So continuing on with geometric probability, let's look at what our formula is. So a formula is similar to normal probabilities formula. It's basically the desired area over total area. The only difference is before it's just the desired number of events over the total number of events. This is area because it's geometry. So let's try an example. A big square has a side length of 24 and has a smaller square within it of area 16. Find the probability of a dart hitting the center of the smaller square. Okay, so we can always start by drawing a diagram. So here's our diagram. This larger square, it has a side length of 24, and we have our smaller square here, which has area 16. And it's not to scale. So our total area would be 24 squared, which is 576. Because we want to find the area of this entire square, and to find the area of a square, you just square the side length. And then, so our geometric probability is our desired area over our total area. Our desired area is 16, which is the area of the smaller square, which we learned in the problem. And the total area is 576, which is the area of the larger square. And we simplify that to get 1 over 36. So now let's try another example. What is the probability of a dart hitting the circle, but not the square? So here we have a circle with radius 5 and a square with side length 2. I did my best in drawing it, and it's not to scale, but it's close enough. Anyways, we want our dart to hit the circle, everywhere that's in the circle, but not in the square. So that's all of this blue shaded region right here. And you can see how there's no blue within this square. So let's first start off by finding our total area. So our total area is going to be the area of this entire circle. And to find the area of the circle, we're going to plug in our radius into the formula pi r squared. R is 5, so we're going to do 5 squared times pi, which is equal to 25 pi. So that's going to be our denominator. Now we want our desired area. The area of this square right here is going to be 4. Because our side length is 2, and to find the area of a square, we have to square our side length. 2 squared is 4. And our desired area is all of this blue, meaning we want to find what the area of the blue thing is. So we're going to take our entire circle, 25 pi, and we're going to subtract 4 from it, which is the area of the square. So our probability is going to be 25 pi minus 4 over 25 pi. So let's start off with our first example. What is the probability of hitting the shaded area? The circle's radius increases by 1 every time. And we start off with knowing that this little circle right here, its radius is 1. And then going off of that, we're going to know that this circle's radius is 2. The next one after that is 3. Then we have 4. Then we have our largest, which is 5. So let's start off with finding our total area. Our total areas can be 5 squared times pi because the radius of this large circle is 5. And to find the area of a circle, we're going to plug it into the formula pi r squared. And we get 5 squared times pi, which is equal to 25 pi. Now let's find the area of our shaded areas, which is here, our orange one, and here, our red one. So our orange one is going to be the difference between this second circle and this first circle. The area of our second circle is going to be 4 pi because the radius is 2. And our smaller circle's area is going to be pi. So subtracting, we have 4 pi minus pi, which is 3 pi, which is the area of this orange shaded area. Now let's move on to our red shaded area. The area of this fourth circle is going to be 16 pi because its radius is 4. And the area of this third circle is going to be 9 pi because its radius is 3. So 16 pi minus 9 pi is equal to 7 pi. So let's now calculate our desired area, which is the sum of this and this. So it's going to be 3 pi plus 7 pi, which is 10 pi. So our geometric probability is going to be the desired area over the total area, which is 10 pi over 25 pi, or 2/5. Now let's move on to our second problem, which is the following. What is the probability of landing a cylinder when you flip it? So we have our cylinder right here. Its height is 10, and the radius of its base is 3. So to land our cylinder, it has to land on one of our two bases. So to do that, to find the probability, we're going to find the total surface area and then the desired surface area that we need. So for the total surface area, the first part is easy. It's the sum of our bases. So it's going to be 2 times 9 pi. 9 pi because the area of 1 is 9 pi and we need the area of 2. And then we have our wrapping, which is technically this circular part around here. So if our height, we can imagine it like a rectangle. So our top part of the rectangle is going to be the circumference of our top base, which is 6 pi. And then our height is going to be 10. So it's going to be 10 times 6 pi. And then adding this up, we get 18 pi plus 60 pi, which is 78 pi. And now we're going to find our desired area, which is just the sum of our two bases, which we already found here, which is 18 pi. So our probability is going to be 18 pi over 78 pi, and simplifying that, you get 9 over 39. And now for our last problem, you are playing a game with dice. If you roll 1, nothing happens. If you roll 2, you get $2. If you roll 3, you get $3. If you roll 4, you lose $4. If you roll 5, you get $5. And if you roll 6, nothing happens. So what is our expected value? So for this, it's a really simple problem. You might overcomplicate it, but basically you're just going to add up all of these, divide by 6, and you get your expected value. So 0 plus 2 plus 3 minus 4 plus 5 plus 0, that all adds up to 6. And then dividing by 6, you get 1. So our expected value for this game is 1. Don't forget to subscribe and like. If you have any questions, you can email info@agoramastercode.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!